Hello everyone, my name is Brandon. I wanted to real quick describe what it is you just saw. That is a simple neural network I made with no machine learning libraries or anything, just visualization libraries like Matplotlib. And it is to solve the XOR problem, which is a fundamental, very old machine learning problem. The reason it's a problem to begin with is that it is not linearly separable, which I'll get to in a minute. So if you don't know what exclusive or XOR is, it is a type of logic gate. So you may have heard of an AND gate or an OR gate, which are pretty simple. AND gates, both inputs must be true for the output to be true, otherwise it's false. OR gates, at least one input must be true for the output to be true. If both are false, the output is false. Exclusive OR is a kind of in between of both of those. Only one input can be true. So you can see here the output is the Y column. It's only true if only one input is true. Otherwise, here you'll see if both are either true or false, the output is false. And so if you were to plot this truth table right here, where let's say A and B are, we call input 1 and input 2, 0, 0 gives us a false, as well as a 1, 1. So here false is purple, yellow is true. So you cannot, there's no possible way with this plot to draw a straight line that classifies or separates the two classes of true and false or yellow purple. As an example here, as you can see, this is kind of what it looked like in the early of the training before it starts to find a solution, before it starts to converge on a solution. We want to know if we can separate these points. So the first thing that might come to mind is, well, duh, just draw two lines. Well, yeah, we can do that. This is an example of what that would look like. Obviously, this is a screenshot from what you saw earlier where it's not actually two lines, but that is intuitively the first thing you might think to do. So you could draw two lines. However, we want to know if there is a way to classify these points, separate the two classes you see here with only drawing one line. And the answer is kind of yes and no. So conceptually speaking, when we add hidden neurons in a neural network, we introduce nonlinear relationships. So it's almost like we're getting to draw two lines, but we're just using one. However, we're not obviously drawing two separate lines because then this wouldn't really be a problem. We have the network transform the 2D points in our input space to a new two-dimensional mapping in our, which we call our feature space. So we're still in 2D if we have two hidden neurons. And in this feature space, the points become linearly separable. And then we interpret that linear separation back into our original input space. Now, this is not a mapping of this new space back to our input space because that's the whole point of this network. There is no mathematical operation we can do to get from this new mapping back to our input space. Otherwise, this wouldn't be a big problem. So when you see here this curved boundary, this is in another two-dimensional space. The mapping we found, it is a straight line. As we can see here, this is the solution we end up finding, or a solution. It doesn't always converge to the same location. But you can see here, this is the feature space. We are able to draw a straight line to separate these two classes. Now, you can see here, though, the points aren't exactly where they are in both plots. So you can see here we have the pinks at 0, 1, 1, 0, but over here we only have them at kind of 0, 0. It's off by a little bit. And then we have the blues at 1, 0, 0, 1. That's because this network found a mapping, and this is the mapping that it found, where we can draw a line to separate them. And then when we interpret this back into our original input space to get an actual solution, this boundary, this straight line becomes this, which looks like two straight lines, but actually at some direction it's making a big swing and coming back around, as we can see here. This is a screenshot, you probably notice it in the demonstration, where it's starting to find a solution. It'll look like it's one straight line, and at some point it kind of swings back and comes over to group these two together. This is still 2 dimensions. We use 2 hidden neurons. We're still in 2 dimensions. We can still do this by taking our 2-dimensional input space and mapping it to a higher dimensional feature space. And for most complex problems, this is typically what you do. So here's an example of when we map our 2-dimensional input space. The same method, just now our feature space is in 3D. And it's a little hard to see because the points don't get super spread apart because they don't need to be, as long as each class is on one side of the plane and the other class is on the other side. When you map the input space to a higher dimensional feature space, these separations become even easier to find, and you are able to find even more complex relationships that can then be, again, interpreted back into your original input space, so you can make a decision on whatever the output of your input data should be. And of course, this pattern still applies if you have a 2-dimensional input space and you map it to a 4-dimensional feature space. It's doing the same thing. It's just looking for a linear separation in a different space. But after 3 dimensions, obviously, we cannot plot 4 dimensions or 5 or 6 or whatever, and it becomes more abstract, which for me personally was a hard thing to wrap my head around, which is a big part of why I made this tool. Is when we talk about mapping to more abstract dimensions, things get a little complicated, but this is essentially what it's doing. We're just mapping to a different, sometimes higher space. And that is my demonstration of a simple neural network learning with some visuals. I really wanted to make this project to kind of open up the black box that can be machine learning. I've written code for several machine learning projects before, but it still seemed like kind of a black box to me. So diving in and writing all the code to learn, do forward and back propagation, all these visuals really helped me understand more of what's going on. This code is on my GitHub. The link will be in the description. You are welcome to check it out, clone it, and play with it however you like. As you could see in the demonstration before, you can also do experiment with seeing higher dimensions with, say, like I did in the video, 7 hidden neurons. Just obviously this will not be available because we cannot plot a 7-dimensional plot. That's not possible. Hopefully everyone was able to get something from this demonstration and explanation. I will be adding to this project in the future, so stay tuned to the GitHub. 2 things I currently already have planned in the works are a similar network, meaning no machine learning libraries, writing all the code myself to do some more visualizations for convolutions on the MNIST handwritten dataset, as well as eventually diving into attention mechanisms and finding some visualizations for that as well. So thanks everyone for watching.